This is the physical science lesson video. This is the physical science lesson video for section 2.1, and as always, if you want my videos in one spot, just subscribe to my channel. So chapter 2 is on the properties of matter. So let's talk about a few of those. So how can we classify matter? Materials can be divided into pure substances and mixtures based on their composition. So pure substances, all the particles are going to be the same. So see, all of these are the same type of atom. All of these are the same type of molecule because it's two atoms bonded together. All of these are the same type of molecule even though they have more than one type of atom. So the first three, every particle looks the same in the sample. Those would be pure substances. Whereas in this one, we have a mixture. Like here's one type of particle, here's another type, and here's another type. So these three would be pure substances. This would be a mixture. Matter that has exactly the same composition is classified as a pure substance. Every sample of a pure substance has the same properties because a substance has a uniform composition. So since a substance is the same throughout, it doesn't matter. Like if I have pure gold and you have pure gold, our gold is going to be the same. It's going to have the same melting point. It's going to have the same properties because they're both pure gold. They have the uniform composition. Substances can be classified as elements or compounds. So anything on the periodic table is a pure substance, and compounds such as sugar, which is known as sucrose, water, as long as it's pure, H2O, those would be examples of compounds, multiple elements bonded together. An element is a substance that cannot be broken down into simpler substances. You can find them on the periodic table. An atom is the smallest particle of an element. An element has a fixed composition because it contains only one type of atom. So in that previous picture that I showed you, this would be an example of an element because it has one type of atom. This element is made of atoms. This is an example of an element. It has one type of atom, but because the atoms are bonded together, this element is made of molecules. So atoms is one atom by itself. A molecule is multiple atoms bonded together. But since all of these atoms are the same, it's still an element. So some elements are made of atoms, some elements are made of molecules. Most elements are solid at room temperature. Some elements are gases at room temperature. Most of them are located on the upper right-hand side of the periodic table, the gaseous ones. Mercury and bromine are liquids at room temperature. So mercury is really, really cool but poisonous, and it's a metal that's a liquid at room temperature. And bromine is kind of a reddish-brown liquid. Each element symbol is either one or two letters. So for example, hydrogen is just an H, it's capitalized. Aluminum is AL, the first letter is capitalized, the second letter is lowercase. So like I just said, first letter is always capitalized. If there's a second letter, it's lowercase. Some element symbols are based on the Latin names for elements. So for example, Rm is gold, that's why gold is Au. Ferrum is iron, that's why iron is Fe. So if you watch the magnetism videos and we talked about a ferromagnetic core, ferro comes from ferrum, which is iron, and iron can be magnetized. A compound is a substance that is made of two or more simpler substances or two or more elements. The properties of compounds differ from those of the substances from which it's made. A compound always contains two or more elements joined in a fixed proportion. So for example, let's talk about salt. Sodium, salt is sodium chloride. Sodium is a silvery soft metal. Chlorine, in its gaseous form, is kind of a light light greenish yellow gas. But yet when you bond them together, it forms a colorless crystal, which we eat as salt. So the properties of compound don't necessarily reflect what it's made up of. Once elements start bonding with one another, they attain new properties. And a compound always contains a fixed proportion. So for example, water is H2O. It's always H2O. It's not like sometimes it's H4O7. It's always H2O, every water molecule. The properties of a mixture can vary because of course the composition of the mixture is not fixed. Mixtures tend to retain some of the properties of their individual substances. So remember, this was our example of a mixture. So think about candy. If you get a mixture of candy, if I reach in here, I might get a lot of gumdrops in one handful, but then I might get another handful and not get that many gumdrops because the properties of mixtures vary throughout. So what type of mixtures are there? Well, in a heterogeneous mixture, the parts of the mixture are noticeably different from one another. So like Italian salad dressing, I can see the different layers. In vegetable soup, I can pick out where's corn and where's tomato and that type thing. Even sand, I can see that there's clearly varying colors in the different grains of sand. So those would be examples of heterogeneous mixtures. Now a homogeneous mixture, it still is variable throughout, but the substances are so evenly distributed that we can't tell the difference. So it appears to be uniform. Please understand that it appears to be uniform. It's not really. So sterling silver, to us it appears to be one thing, but it's a mixture of metals called an alloy. Tap water. Hopefully when you turn your faucet on, it all looks the same. If it doesn't all look the same, you really have a problem. But there's lots of dissolved compounds in tap water. Why do you think people are always wanting to filter it? To get all that stuff out. Okay, Kool-Aid, if you dissolve all the sugar, it all looks like one thing, but we really have water, we have Kool-Aid powder, we have sugar all mixed together. So when you have matter, you can either have a pure substance, and if it is, it's either an element, which is all one type of atom, or a compound, which is multiple atoms bonded, but every particle should still look identical. Or you can have a mixture. You can have a homogeneous mixture where it's so similar looking when we look at it, we can't tell the difference, so it appears uniform. Or you can have a heterogeneous mixture where we have two obvious different parts to our mixture. Based on the size of the largest particles in a mixture, it can be classified as a solution, a suspension, or a colloid. So let's talk about what those are. So when the substances dissolve and form a homogeneous mixture, so remember that's the one where we can't tell the difference, it appears uniform throughout, the mixture forms what we call a solution. Properties of solutions: they do not settle, they cannot be filtered, they allow light to pass through, and they have very small particles. Examples include Windex, grape juice, and gasoline. I will always use the example of Windex because if you know Windex, you already know this stuff, so it does not settle. Do you need to shake Windex up before you use it? No. There's not going to be stuff sitting at the bottom of Windex. Alright, does it allow light to pass through? Yes. You can see through Windex, it just makes everything look blue. I skipped one. Cannot be filtered. Think of a coffee filter. If I pour Windex through a coffee filter, is it all going to pass through? Yes. We're not going to have chunks of stuff left behind. And then it obviously has small particles because, again, I can see straight through it. It just makes everything look blue. So a suspension is a heterogeneous mixture that separates into layers over time. So properties of suspensions include that it does settle over time, it can be filtered, it scatters light, and it has large particles. Examples include Italian salad dressing, muddy water, and paint. So Italian salad dressing is the example I'll use in class all the time. Okay, because you know when you buy Italian salad dressing, what do you have to do before you use it? You gotta shake it up. Because what happens? It settles over time. You already know this. Alright? Next thing is can be filtered. If I pour Italian salad dressing through a coffee filter, are we going to catch all those big particles at the bottom? Yes, like the oil and stuff will pass through, but all of those spices, you're going to catch that in the filter paper. Scatters light. Think about if I shake this up. I can't just see through Italian salad dressing once I shake it up. Now I can see through the oil layer, but that's not the mixture part. Once I shake it up, I can't really see through it. And I know it has large particles because I can physically see some of the particles. They're so large in Italian salad dressing. Now they're not always going to be that large, but that's why I like to use Italian salad dressing as my example, because I can physically see the particles. And then a colloid kind of comes in the middle. A colloid contains some particles that are intermediate or medium sized. So properties of colloids is they do not settle, cannot be filtered, it will also scatter light, and it has medium sized particles. So examples include milk, ink, and Jell-O. So I like to use milk as my example. So again, milk, do you need to shake it up because dust settles at the bottom before you drink it? I hope not, otherwise you might want to check that expiration date. Cannot be filtered. Again, if you pour milk through a coffee filter, all of it should pass through. If you're getting chunks, again, check the expiration date. Or maybe you're buying fresh milk where the cream has separated. We'll talk about that in the assessment. It scatters light. So again, I can't see straight through milk. Okay, I can't, like even in this picture, we can't see through it. And then it has medium-sized particles. So the particles are big enough to kind of block the light so I can't see through it as well, but they're not big enough where I can see particles floating around in my milk. Again, check the expiration date. Chunky milk has expired. Alright, so section assessment. Why does every sample of a given substance have the same properties? Well, because a substance is uniform throughout. A substance is uniform throughout. Number 2, explain why the composition of an element is fixed. Well, elements are only made of one type of atom. So that means the composition is going to be the same. Okay, elements are made of one type of atom. So number 3, describe the composition of a compound. Well, the composition of a compound is going to be uniform, but it's going to be made of particles that are multiple atoms bonded together. Okay, so it will be uniform, but the particles will be multiple atoms of different elements that are bonded together. Next one, why can the properties of a mixture vary? Well, remember, a mixture has a variable composition. That's its definition, has a variable composition. And so depending on, like with the candy, if I reach in there, sometimes I'm going to get more of one type of candy than the other. So the reason that the properties vary is because, of course, the mixture itself has a variable composition. It's just not the same throughout. And then next one, on what basis can mixtures be classified as solutions, suspensions, or colloids? Well, the easiest way is by particle size. Solutions have small particles, suspensions have large particles, and colloids have medium-sized particles. Okay, so it can be classified based on its particle size. So explain why silicon dioxide cannot be the only compound in a sample of sand. So one of the main components of sand is silicon dioxide. But why can it not only be that? Well, the thing is, different sand looks different. Even if you scoop up one handful of sand at the beach, even looking at the grains, they're going to look different. So that shows us that sand is more than just one compound. So it can't all be silicon dioxide. There must be other things in there also. And so why? Because every grain of sand doesn't look the same. All right, and then last one. Fresh milk is a suspension. Okay, after fresh milk is homogenized, it is a colloid. Okay, so when you first get milk out of the cow, it is a suspension, which means it's going to separate over time. All right, however, when we buy it at the store, though, it doesn't separate. That's because when we buy it at the store, it's been homogenized. And so now it is a colloid. So what happens to the size of the drops of fat in milk when it's homogenized? Well, if it goes from a suspension, which is known for having large particles, to a colloid, which is known for having medium-sized particles, what happened to the size? We decrease the size of the fat molecules. Okay, so we decrease the size of the fat to make it go from a suspension to a colloid. Alright, so hopefully now you understand a little bit more about classifying matter between pure substance versus mixture, and then between element and compound, or homogeneous and heterogeneous mixture.